For perimeters and areas of shapes. We're going to find the perimeter and areas of parallelograms, rectangles, trapezoids, rhombus, so on, triangles, all those different shapes, and also pentagons, hexagons, any of the polygons that we've dealt with. We're going to find the perimeter and the area. Area always has to be in square units. So when you give your units at the end of it, when you're giving your answer, it's got to be in square units. So if you start off with feet, then your units at the end for area have to be feet squared. And what you're doing with the units, if we're trying to find the units of this, what you're actually doing is you're finding the area. So you're finding how many little squares it takes to fill up that shape. That's why it's units squared. Perimeter is always just in regular units. So if you start off with feet and you're trying to find the distance around this shape, you're just going to find the distance all the way around, and your units are always just going to be in regular units. So something like meters. So it'd just be 27 meters or whatever. Make sure you give your units on every answer. Area, square units, perimeter, regular units. Perimeter, easiest way for perimeter, you just add up all the sides. You know the lengths of each side, you just add them all up. There's a formula for every shape, but instead of knowing all the formulas, it's easier if you have some shape, whatever that shape is, you just add up all the sides, the lengths, and that's going to give you the perimeter. For area of a square is just S squared, where S stands for one of the sides, so you just take one of the sides and times it by itself. So this could also be written as just S times S. Remember, a square is also a parallelogram, it's also a rectangle, it's also a rhombus. So any of the formulas that you learn for parallelogram, rectangle, or rhombus would also work for a square. A parallelogram. No, a rhombus. In a rhombus, the area is 1/2 times the diameter 1, or diagonal 1 times diagonal 2. Another way to write this is diagonal 1 times diagonal 2 divided by 2. So you can multiply these two together first, then divide by 2 and get your answer. That's if you know the lengths of the diagonals. If you don't know the lengths of the diagonals, it's also a parallelogram, and the formula for a parallelogram that we're going to go over here in a minute is base times height. Well, in a rhombus, the base and the height, you're going to have to be given it somehow by, if we look at a rhombus, they're going to give you a height. They'll probably be given something like that, with a right angle symbol in there. So that will be your height, and then your base will be wherever that right angle sets. That's your base. And remember, base doesn't always mean bottom. It could be turned sideways or something else. So you could use this formula also. It just depends on what information you're given. If you're given the lengths of the diagonals, then you could use that. If you're given a picture that looks more like this, then you probably want to use the base times height. A kite's the same thing as, or it's the same formula as a rhombus. In a kite, again, this formula could be written diagonal 1 times diagonal 2 divided by 2. You got to make sure that you're doing the whole length of each diagonal. So that whole length might involve, this one, remember, is being bisected. So it might involve doubling that length, or one of the lengths, or adding these two together to find that whole the whole diagonal. So that's for a kite. Next, a rectangle. A rectangle is base times height. Remember, a rectangle is also a parallelogram. It's also a square, or squares are also rectangles, so on and so on. Another formula you might have seen in the past is just length times width. Either one of those formulas will work. Just remember that one of these is your base and one of them's your height, or one of them's your length, one of them's your width. Whichever one you want, it doesn't really make any difference which one's which. So that's for a rectangle. Parallelogram, base times height, this is going to be your base, wherever this right angle symbol sets, the height's going to be given by something normally drawn inside, or it could be drawn outside with a right angle. That could be your height. But it's just going to be base times height on that one. Make sure you can't do this side times this side for a parallelogram. It doesn't work the same as it does for a rectangle. Triangle, 1/2 times base times height. Again, you're going to be given the height with something going down. If it happens to be a right triangle, then this is going to be your height, and this is going to be your base. The legs of the right triangle are your height and your base. This formula, again, could be written base times height divided by 2. Means the same thing. Works out the same way. It might be a little easier to use this when you're using a calculator. A trapezoid, the formula for a trapezoid. In a trapezoid, you're going to be given the height, again, with the right angle symbol, probably drawn inside. It could also be drawn out here somewhere. That could be your height. And then in a trapezoid, it's going to have 2 bases. Remember that the bases are the parallel sides. The bases are always the parallel sides. So you're going to have 2 bases. It doesn't matter if this is base 1 and this is base 2 or vice versa. It doesn't make any difference. This formula could also be written height, parentheses, base 1 plus base 2, close the parentheses. You got to do what's inside the parentheses first, then multiply by the height, then hit equals, then divide by 2. That might be an easier way to do it using the calculator. You just got to remember your order of operations and do this part first, hit equals, then times by the height, hit equals, then divide by 2. In a polygon, if it's a regular polygon and we're trying to find the area, the formula is going to be this. 1/2 times P times A. The P stands for perimeter. And you find the perimeter just by adding up all the sides. Here we have 6 sides. Since it's regular, if I told you that this side was 4, all of them is going to be 4, and you just add them all up or take 4 times 6. The A stands for apothem. That's a new term. Apothem starts at the center and goes to the midpoint of one of the sides. That's the apothem. That's the A. The part that starts at the center and goes to one of the vertexes or vertices is called the radius. That's an R. So that part right there is R. We're going to talk about something here in a second that deals with that. So this formula, if they told you a shape, if we had this shape, this 5-sided shape, and it had something like this, and they told you that was 7, and that this was supposed to be regular, I know mine doesn't look like it, maybe this is 5, you just find 5, 5, 5, you find that whole perimeter, which would be 25, that's the perimeter, and the apothem is 7, and then you just plug into this formula. Perimeter times apothem divided by 2. And again, this could be written P times A divided by 2. And that's going to give you the area of that. Remember, your area is always in square units. Don't forget this formula. Sum of the interior angles is always n minus 2 times 180. We had that on the other part of the notes. On the notes that I gave you, there's 2 other formulas. One of them is A equals 1/2 times n times the sine of 360 divided by n over, times r squared. This one is best to use if you just know the radius. So you could plug in here. You're going to know the number of sides. In this case, it'd be 6. And remember that this right here is a radius. If you know that length, then you could just plug in this formula and let your calculator do all the work for you. So that's if you know the radius. The other formula looks like this. A equals, and these formulas are really hard and scary, but they're not all that hard because you're just plugging in numbers and letting your calculator do the work. 4 times tangent of 180 divided by n. This one works if all you know is the length of one of the sides. So if you just know a side length, then you could use this formula because all you got to know is how many sides, which is n, and the length of the side. So these formulas, this one, if you just know a radius, this one, if you just know the length of a side, this one is best if you know the length of a side and the apothegm. Remember, that's an apothegm there. So 3 different formulas, just depends on the information that you know. An equilateral triangle. There's a formula on your notes for an equilateral triangle. Remember, an equilateral triangle, all the sides are always congruent. You could use the formula for a triangle, but another formula, if all you know is it's equilateral and you know the length of one of the sides, is this right here. And again, oops, let's get rid of that because I messed it up. Square root of 3 over 4 times the length of a side squared. So if you know this side's 8, that means all the sides are 8. You're just going to take your calculator and you're going to take the square root of 3 divided by 4 times 8 squared. And that's going to give you the area for that triangle. That's a real easy formula. Again, your calculator is doing all the work for you. So that's formula if it's an equilateral triangle. That only works for equilateral triangles. Circles. We talked about circles already. Remember the formula for circumference of a circle is diameter times pi. The formula for area of a circle is pi times radius squared. Pi times radius squared. So that's for a circle. For an ellipse, an ellipse looks something like this. It's like an oblong circle. It could also look like this. You may have heard it called an oval at some point in the past. In an ellipse will always have 2 radii. It'll have one radii going the short way across it and one radii going the long way across it. So it's going to have 2 radii. If you're trying to find the distance around the outer edge, it's like the circumference or the perimeter of that. Then the formula is P equals 2 times pi, and it looks like a big long hard formula again, but all you're doing is plugging in numbers. You take radius 1 squared plus radius 2 squared. Divide that by 2. You're going to have to do all this stuff inside first. Maybe write down that number. Then take the square root. Then take it times pi. Then take it times 2. Again, all you're doing is you're taking those numbers and sticking in there and letting your calculator do most of the work. If we're doing an ellipse and we want to find the area of an ellipse, the formula for area of any ellipse is just pi times radius 1 times radius 2. So if you're trying to find the area inside this ellipse, just take radius 1 times radius 2. Again, don't make these formulas, some of them, I know they look difficult, but all you're doing is plugging in numbers in those spots and then letting your calculator do all the work. One more formula for a triangle is Heron's formula. Heron's formula works for all triangles, and it's this. And we're not going to do a whole lot with Heron's formula, but I'm going to show it to you. It's S times S minus A times S minus B times S minus C, where S equals A plus B plus C divided by 2. And in any triangle, whatever that triangle looks like, you're going to have one side's A, one side's B, one side's C, and that's where this is going to come from. So if you just know all three sides of the triangle, then you could use Heron's formula and figure out what S is, and then take that S and stick it in there and do all that math. Again, we're not going to do a whole lot with this, but that's Heron's formula, and sometimes it's real useful. That way you don't have to go through and try to find the height of the triangle or the base of the triangle, and so on and so on. So hopefully that'll help you with all these formulas for area and perimeter.